You asked me if an ordinary person, by studying hard, would get to be able to imagine these things like I imagine. Of course, I was an ordinary person who studied hard. There's no miracle people. It just happens they got interested in this thing, and they learned all this stuff. They're just people. There's no talent, a special miracle ability to understand quantum mechanics or a miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and time, then he's become a scientist. Well, when I'm actually doing my own things and I'm working in the high, the deep and esoteric stuff that I worry about, I don't think I can describe very well what it's like. First of all, it's like asking a centipede which leg comes after which. It happens quickly, and I'm not exactly sure what flashes and stuff go in the head. But I know it's a crazy mixture of partially equations, partial solving of the equation, then having some sort of picture of what's happening that the equation is saying is happening, but they're not that well separated as the words I'm using. And it's a kind of a nutty thing. It's very hard to describe, and I don't know that it does any good to describe it. And that is something that struck me that's very curious. I suspect that what goes on in every man's head might be very, very different. The actual imagery or semi-imagery which comes. And then when we're talking to each other at these high and complicated levels, and we think we're speaking very well, and we're communicating, but what we're really doing is having some kind of big translation scheme going on for translating what this fellow says into our images, which are very different. I found that out because at the very lowest level, I won't go into the details, but I got interested in, I was doing some experiments, and I was trying to figure out something about our time sense. And so what I would do is I would count, trying to count to a minute. Actually, it took me, say I count to 48, then it would be 1 minute. So I calibrate myself, and I would count a minute and 48. I think I was count seconds, but it's close enough. And then it turns out if you repeat that, you can do very accurately. When you get to 48 or 47 or 49, not far off, you're very close to a minute. And I would try to find out what affected that time sense and whether I could do anything at the same time as I was counting. And I found that I could do many things. I could, there were some things that not. For example, I had great difficulty. I was in the university, and I had to get my laundry ready. And I was putting the socks out, and I had to make a list how many socks, and there was something like 6 or 8 socks, and I couldn't count them because the counting machine was being used, and I couldn't count them until I found out I could put them in a pattern and recognize the number. And so I learned a way after practicing by which I could go down the lines of type in newspapers and see them in groups 3331, that's a group of 10, 3331, without saying the numbers, just seeing the groupings. I could therefore count the lines of type I practiced in the newspaper at the same time I was counting internally the seconds. And so I could do this fantastic trick of saying 48, that's a 1 minute, and there are 67 lines of type, you see. It was quite wonderful. And I discovered many things I could read while I was, Yes, I could read perfectly all right while I was counting and get an idea of what it was about. But I couldn't speak. I couldn't say anything. Because, of course, I was when I count, I sort of spoke to myself inside. I would say 1, 2, 3, sort of in the head. Well, I went down to the breakfast, and there was John Tukey was a mathematician down at Princeton at the same time, and we had many discussions, and I was telling him about these experiments and what I could do. And he says, that's absurd, he says. He says, I don't see why you would have any difficulty talking whatsoever, and I can't possibly believe that you could read. So I couldn't believe all this, but we calibrated him. It was 52 for him to get to 60 seconds or whatever. I don't remember the numbers now. And then he'd say, all right, he said, what do you want me to say? Mary had a little lamb. I can speak about anything. Blah, 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 blah. 52. It's a minute. And he was right. And I couldn't possibly do that. And he wanted me to read because he couldn't believe it. And then we compared notes, and it turned out that when he thought of counting, what he did inside his head when he counted was he saw a tape with numbers that when clink, 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 the tape would change with the numbers printed on it, he could see. Well, since it's sort of an optical system that he's using and not voice, he could speak as much as he wanted. But if he had to read, then he couldn't look at his clock. Whereas for me, it was the other way. And that's where I discovered, at least in this very simple operation of counting, the great difference in what goes on in the head when people think they're doing the same thing. And so it struck me, therefore, if that's already true at the most elementary level, that when we learn the mathematics and the Bessel functions and the exponentials and the electric fields and all these things, that the imageries and method by which we're storing it all and the way we think about it could be really, if we could get into each other's heads, entirely different. And in fact, why somebody sometimes has a great deal of difficulty understanding a point which you see as obvious, and vice versa, it may be because it's a little hard to translate what you just said into his particular framework and so on. Now I'm talking like a psychologist, and you know I know nothing about this.